Hi, welcome to part 3 of our second derivative test. We've been talking about how the second derivative can help us find a relative maximum by looking at the concavity. For example, if a function is concave up, we know that the relative minimum is at the very bottom. Our critical number at the bottom is the relative minimum. If a function is concave down, we know that the critical number is on top. So we have a relative maximum. So concavity really can help us find out if we have a relative max or minimum. So we've also talked about how we don't always have to use the second derivative test to determine if we have a maximum. We can also use the first derivative test. So the AP will sometimes give you a question like this. So suppose that a function f has a continuous second derivative, and that they give us the values of the function. At 3, they give us the slope of the function at 3, and they tell us the concavity at 3 is -2 of f. Let g be a function whose derivative is given by this. G prime of x is equal to the product of x squared minus 9 and 2 times f of x plus 5 times f prime of x. Then it asks, does g have a local maximum or local minimum? Now, we would typically want to use the first derivative test, but we only know about the values of f. We don't know anything about g itself. In order to use the first derivative test, at x equals 3, I would have to know something before 3 and after 3. They don't tell us anything about that. So our first derivative test here will fail. So we have to determine if we have a local maximum. Our first step is just to guarantee that we have a critical number at x equals 3. So to do that, we just have to take g prime of 3. And that's not too bad to do. We would get 9 minus 9. And it doesn't matter what the rest of this is, because what is 9 minus 9 but 0? So this is equal to 0. Therefore, g of 3 is a critical number. Now, since it's a critical number, we just want to know, is this going to be a relative maximum or relative minimum? To do this, we use our second derivative test. So I'm going to take the second derivative of g double prime of x. This is my product rule. It's the first, so it's going to be x squared minus 9 times the derivative of the second. This is going to get ugly. 2 f prime of x plus 5. Well, the derivative of f prime will be f double prime of x. Plus, don't forget the second, which is 2 f of x plus 5 f prime of x times, oops, ran out of room here, the derivative of the first, which is 2x. And now we want to find the second derivative at 3. So if I plug this in, this becomes 9 minus 9. And again, none of this right here really matters because all of this just becomes 0. So we're really only interested in this part. 2 times f of 3 plus 5 times f prime of 3 times 2 times 3. And I just plug all that in. 2 f of 3, we're told, is -4 plus 5 f prime of 3 is 1, and we're going to multiply that by 6, 2 times 3. And if we do the math here, this becomes -8 plus 5, so I get -3 times 6, which is -18. Now notice my second derivative is less than 0. So what does that tell us? That the function is concave down. And I ran out of room down here, so we can write therefore, g of 3 is a relative maximum. Notice I always draw that out. It's a relative maximum, and that is because the second derivative at 3 is less than 0. And there is our answer. Alright, so I hope you enjoyed the video, and I will see you all later. Bye-bye.